Hey guys, so someone, actually a couple of you, asked me about question 12 on the study guide, which makes sense because question 12, if you refer to it, um, involves solving a systems of equations. And I don't think we covered this in class as much as I would like to have covered it because we just have so much going on. And then I didn't get to cover it on the study guide. So I want to make sure that you guys see this from me, so that you can see exactly how I would solve this. There's a number of different ways, and I don't know if you go online, you may find a number of different ways. But let's work through this together so you guys have this in your notes. So let's turn this down. Let's see. There we go. All right, so what we have, let me see how far up I can go here. What we have is a negative 9x plus 2y is equal to 25. And then I'm also given 3x plus 5y is equal to a negative 14. All right, so when I look at this, what I see, okay, there's a number of different ways we can solve system of equations. And there are a number of different methods for eliminating variables or solving for a particular variable. But what I want to use here is the elimination method. So if you want to look some more of these up, it's the elimination method. And the reason we call it the elimination method is we want to try to manipulate one of these equations so that when we either add or subtract the equations or combine the equations in some form or fashion, that one of the variables are eliminated. One of them is eliminated. So in my case here, what I want to eliminate is the x. I see that I have a negative 9x in this first equation. In the second equation, I have a 3x, but I know that if I were to take that second equation and multiply it by 3, let's rewrite this thing again. I'm going to leave the first equation just as it was, a negative 9x plus 2y equals 25. But that second equation now becomes 9x plus 15y is equal to a negative, 42. Bear with me with my math, okay, my mental math. All right, so when I do that, if you notice, my 9s here are opposites of one another. And if I were to add these, those would eliminate, the elimination method. Okay. Now, what we're going to do now is add everything else. So in this case, I would have 17y. And then if I have, let me do some math, 42 and 25, I really cannot add in my head. I am left with 17. Okay, actually a negative 17. So what you notice is that I eliminated the x variables there. The only variable that was left was the y, and because I only have one variable, I can easily solve for that by dividing both sides by 17, and that gives me that y is equal to a negative 1. Okay, so when you solve these linear equations, you don't want to just find one of the variables, right? We are actually looking for an ordered pair. So what I found in this case is that my y is negative 1. So I've got to find my x. It doesn't matter where you go to find that x. I can substitute back into either one of these equations. Either one will be fine. Let me use a different color. I don't know what this green looks like. Let's try the green. So I can maybe do 3 times x plus 5 times that negative 1. I'm using this equation. The original equation is equal to a negative 14. So 3x minus 5 is equal to a negative 14. I just multiplied that negative 1 and that 5, got negative 5. I'm going to bring that 5 to the other side. And if I do that, that is going to give me 3x is equal to a negative 9, right? Now I want to isolate that variable, that x, so I'm going to do that by dividing both sides by 3, so I get that x is equal to a negative 3. Now you can check these. When you get to this point, when you think you have your answer, you can check these by taking and substituting those values, your x and your y, those points, back into those equations. And if it works, then you know you have the answer. If it doesn't work, then we know we need to go back and try something new. Excuse me. Another method of solving these is I could take each one of these equations, set them equal to, solve them for y. In other words, put them in slope-intercept form, right? And graph the equations. And where those two equations meet, where they cross, that is the solution. So if I were to take both of these and put them in slope-intercept form and graph them in either Desmos or in my calculator, what I would find is that they intersect at one point, and that point is at negative 3, 1. Okay, I hope this helps. Again, if you guys have any questions, do not hesitate to reach out.